Okay, we're live.
Hello, hello.
Hello, hello. You know the drill, unless this is the first time. If this is the first time you're in this show, it's very easy to explain. We did not prepare anything. We don't know what to talk about. We can only answer your questions. So type your questions over there. We go through them. First come, first serve. Don't be too lazy, because if you write it too late, we will not have time to answer them. So that's the drill. And we got 2 new members of the channel. Alex, welcome. Thank you so much. That's amazing. And Stefan as well. Amazing. Now, let's start with the first one from Thomas. Oh, this is going to be fun. Is there any serious Kubernetes MCP development happening in the ecosystem? There is one from Manusa Kubernetes MCP server, but it doesn't look like it's gaining traction. I have a long answer to this one. So I don't know. You want to start first, Scott, or shall I start thrashing it all together? You want to go first? Go for it.
So I'll say something short on this one. The answer is that I think MCP servers today are like the initial operators in Kubernetes, and most of them are terrible. And there are a very few of them that are showing what the potential may be of MCPs, but I think that it's in its infancy right now. The Kubernetes MCPs, most of them that I've tested have been very, very, very bad. I think there are projects that are showing potential in this area, especially K-Agent in my mind, that shows potential of becoming something big in this area. I don't think any of them are there yet. So there is development happening. It is currently very dispersed, though. It's a bunch of people just trying stuff. And I think once MCP settles down a bit, the hype settles, and we actually figure out how we're going to do things in the right way, I think that's when we'll get one. Because building the MCP server is not the challenge. It's making sure we get the MCP technology to the state where we can actually utilize it to its full potential.
Yes, I agree with everything you said, with additional comments. I think that the first iterations of MCPs were, hey, my agent should talk to something. Let's say Kubernetes, just because it's in this comment, right? I'm going to create an MCP that basically mirrors Kubernetes. Hey, there is going to be get, there is going to be apply, there is going to be delete, there is going to be describe, right? And I think that, and that can, same logic is happening, for example, for APIs. Oh, I have API of this service. Let me create an MCP that will mirror that API. And I think that that's completely wrong.
Yep.
For a couple of reasons. First, you can think of terminal, and I'm now talking from the perspective of software engineering. I'm not talking about MCPs outside software engineering, right? I consider terminal being an MCP in a way, right? I don't need Kubernetes MCP that will expose Kubernetes API as it is, because my agent is perfectly capable of executing kube control apply, right? Models know about it. Agent goes to the model and says, hey, I need to fetch something from Kubernetes. Model says, execute kube control apply, get, right? And agent executes it, right? We don't need MCPs for that. That's just the first wave. What we need MCPs is more focused on user intention. Well, let's say that, and I'm saying this because that's the MCP I'm working on right now. Just spitballing here idea, right? And it's very much related to Kubernetes. And the way I focus the first tool in that MCP is, okay, ask user to describe intent. An intent can be, I want to deploy application in Kubernetes, right? Ask it questions, and then MCP will generate that. And how it will generate? By executing within the MCP, hey, get all the CRDs, get all the schemas, combine it with what the user asked for, try to figure it out. Agent inside of MCP does the work, right? It's more focused on what the user might need than just pure kube control get, right? We don't need MCPs for that. Right. And a good example, for example, without entering whether it's really well implemented or no, would be what AWS is doing right now, right? They have MCP for EKS cluster, right? Hey, create a cluster. And behind the scenes, we're going to do whatever, right? And you will need to specify whichever parameters. But it's not, they're not exposing, at least not in that MCP, hey, there is a subnet endpoint, and there is a VPC endpoint, and there is this endpoint and that endpoint that mirror our API. AWS CLI can do that. An agent can use that CLI to do the same thing, right? But hey, we are wrapping this, creating, exposing EKS as a service, as MCP. That's valuable, right? That's not something that LLM necessarily knows how to do right.
Right. APIs are created for machine to machine or code to machine, whatever, typically, and MCPs are for human to machine. So the difference is that we have to build things that are at the intent level, at the process level of, I want to create an EKS cluster. The fact creating an EKS cluster is probably over 24 API calls that have to be made, plus then API calls of polling and things like that for this to finish, and then I can do that. It's a lot of logic in there. And one call, create EKS cluster, right? It's like the EKS cuddle versus go and do each resource in Terraform.
Exactly.
Right? Or AWS CLI.
Exactly. It's that MCP from AWS reminds me, it feels more like EKS, exactly, like EKS cuddle that you mentioned than AWS CLI, which makes perfect sense to me. Without entering the specifics of that MCP, kind of that would be a much longer discussion, but more or less an idea. Okay, what's next? From Shabir. Do you think Crossplane makes it easier to promote infra changes compared to Terraform? Yes.
100%.
I wouldn't be working with Crossplane if I would think that. So I do strongly believe, ignore Crossplane for now, because everything I'm going to say can be applied to other tools, right? We should be leveraging the power of Kubernetes to expose existing APIs, to create your own APIs, to drift detection, reconciliation, ecosystem, Argo CD, Flux, monitoring. All those things are extremely powerful in Kubernetes. And I'm going to say yes to that question if you change Crossplane to anything that is Kubernetes native way to manage whatever. I don't even care whether it's infrastructure or applications or something like that.
So I will say, on this, I will say yes and no. Actually, I think it's a bit nuanced, the answer to this. I am a huge proponent. I hugely support Crossplane, and it's my preferred tool. However, there are benefits that the Terraform model has for promotion of infra specifically. Things like Terraform Plan, right? The fact that it is very easy to know when you're talking about promotion what is going to change, which is a part of that promotion flow. The promotion itself, much easier with Crossplane. But there are challenges that you will hit, especially if you are coming from the Terraform or, let's say, the traditional IAC world. Traditional IAC world, in my mind, is Terraform, Pulumi, CloudFormation, any of these things where I can get a diff before it gets applied. It basically creates a DAG of all my resources. It's able to do the three-way merge that Terraform does and all of that. That has its benefits in the wider term of promotion in terms of like validation between stages and things like that. So
yes,
Crossplane makes that harder because you have to trust the platform a lot more than you do with Terraform. So there are challenges in that, but the actual promotion of the database, the act of promoting a change from one environment to the other is much easier, partly because of Crossplane, and very much so also because of the Kubernetes ecosystem. GitOps, mechanisms, things like that we have, Kyverno policies, Flux CD, or the inferior other one. Right? Like all of these tools that we have are built to give us that capability.
Okay, now that you said inferior, I'm going to force you, just because you said it, I'm going to force you to actually, if I find it, where the heck is it? I know I have it somewhere. Where is it? There we go. I'm going to force you to now promote Argo CD. Just because you said it's inferior.
No, I'm going to promote a commercial company that is doing exactly what should happen in the open source world, where there is a very popular open source tool, and you should be going and supporting the companies behind it, like Codefresh, who are behind an open source project and giving huge amounts to the open source community and helping them keep a sustainable model. So go to learning.codefresh.io, learn from the different levels, whether you're a beginner, intermediate, or just want to geek out on real expert things in Argo CD. So go to learning.codefresh.io, learn all about GitOps with code Victor for 50% off.
There we go. He's going to burn in hell for this. for promoting Argo CD. There we go. You heard it here first. Where were we? Let me see. Okay. Any hints to automate the deployment, some operator across multiple Kubernetes clusters in a progressive manner so that updates roll out incrementally? I feel that there are actually two questions there. How to promote in multiple Kubernetes clusters and how to promote something progressively within a cluster, right? If I get it right? Which probably and we can discuss other options, right? The first one would be GitOps. It's relatively easy to set up. Hey, this cluster watches this repo, that cluster watches this repo. It can be automated, it can be manual. It can be same repo if it's manual. And then progressive would be, but it can be tough though, even though it's easy to set up, right? Argo rollouts or what's the name? Flagger, right?
Yeah.
Depends what you mean by progressive. Whether you mean progressively roll out to ever increasing number of users, or progressively roll out from across multiple clusters.
Exactly. Right. And I think that in the end, one of the things that, I've been working with, a bunch of different companies over the years, right? With the whole idea of, re-architecting platforms and building platforms and all of that. And a lot of companies like today, let's say, have very, very complex, let's say, Jenkins pipelines or GitHub Actions or Circle CI or whatever tool they're using, that are doing all this complex logic, doing kubectl apply of this, waiting for something to finish, going and applying that and doing things, and then doing the promotion between environments, right? So they'll do dev, and then they wait for an approval, and then it goes to stage, and then wait for approval, and then right? And they have this whole thing laid out. There's, I think, a misconception that people have that GitOps replaces that, and that GitOps is just just push to Git. The answer is no. I don't think that that's true. I think that pipeline needs to stay. The difference is that the pipeline never talks to Kubernetes. The pipeline pushes to Git, which syncs it down to the cluster. So you're not changing your promotion flow. If your promotion flow today without GitOps is doing things imperatively, you can also do an imperative promotion where each of the steps, though, makes the state declarative. So instead of kubectl applying, you're Git committing and Git pushing, basically. And that's the major change here, I think, because the pipeline was never the issue. The issue was reproducibility, my MTTR, how do I make my environments resilient? And that's where GitOps helps us. So people have to stop this fight of CI versus GitOps. No. CI/CD pipelines with GitOps as a target.
One beef I have with both Argo CD and Flux is that they're using the word CD. That's a hill I'm going to die on. It's not CD. It's not continuous delivery or continuous deployment or whatever you want to call it. Pipelines, the whole process from pushing to Git until it is running in production, that's CD.
Yep.
CI would be a subset of that process. Kind of like with CI we get here, with CD we get here, So CI in my head is a subset of CD. It's a hill I'm going to die on. And I know that many people don't agree. And another thing important I feel is that there are things that are not solved in Kubernetes and probably not being planned to be solved, like pipelines. I mean, they can run in Kubernetes, but I don't think that that's really being solved as trying to make it Kubernetes native or something like that. But things that are solved, if you're using Kubernetes, you just accept Kubernetes way of doing. That would be the promotion. That's Argo CD or Flux or one of those tools, right? Just do it.
Exactly.
And what you might want to see is how that what Scott was explaining. How do we fit parts that are not Kubernetes domain, like the pipeline itself, and how do we plug Kubernetes way of doing stuff, like promotions, into that, right?
Right.
And last thing, small correction that you made, and which probably wasn't intentional. It's okay if pipeline or something else talks to Kubernetes. It is not okay if it writes anything to Kubernetes.
Correct. It should read from Kubernetes. It can talk to Kubernetes to read, to wait for the service to be up, to then go and run 100%. It should never be applying anything to the cluster. It should be applying it to Git. And that's a key one, for sure.
Okay, the next one from Taiko. I'm probably inventing names. I don't know. How to efficiently deploy resources to Kubernetes. Some advice on how to use HPA. Manage Kubernetes. Autoscaler, should we prefer it? That's multiple questions. I'm going to go short, and then Scott is going to go wild for 15 minutes, I bet. How to efficiently deploy the Kubernetes. We already addressed that. Use GitOps. When to use HPA. I would say use it whenever your application is stateless. So not necessarily for databases. They tend to have their own mechanism to scale. But for stateless applications, just use it, right? I tend to use HPA even if I have one replica in an environment, but then in production I would have multiple replicas. Why not? And manage Kubernetes, I'm a huge fan of managed Kubernetes. Autoscaler, that's KEDA. Use KEDA.
Well, autoscaler of the clusters?
Sorry. I'll use KEDA instead of HPA unless you have very simple scenario memory, right? And for my brain stopped. What's the name of the autoscaler? Carpenter. Yes, but Carpenter works only Azure or did they extend
Azure
it
outside? Azure and AWS. So it started AWS. It was extended to Azure and is now called the Node Auto Provisioner in Azure. There isn't one for Google as far as I know, and there's an experimental one for Cluster API. The experimental one for Cluster API, though, will work against anything if you're using Cluster API like you should be doing as well to manage your clusters.
Yeah. Anything else to add?
Yeah, so the only thing that I would say is never use HPA. Never use HPA directly. Always use KEDA. Even for the simple use case, use KEDA, which ends up creating an HPA. The complexity difference is so minor, and it is better for you to learn the API from the get-go of KEDA so that when you have a use case where you can really gain the benefits of KEDA, it's not learning a new API. It's not learning a new this. It's KEDA is KEDA. And I believe that it should always be used, and you should never use the core HPA. Like, KEDA uses HPA under the hood. You just shouldn't be creating them directly.
One more thing. This is a minor thing, but kind of important. Probably never at all, but if you're using HPA or KEDA, don't specify number of replicas in deployment, please. That can mess it up.
Yes. Make sure not to put them in Git, your replicas, and make sure both FluxCD and the other one have documentation very clearly stating how you can set rules of like what not to reconcile, specific paths on types of resources, even though you tell people not to apply a number of resources, like a number of replicas, have a policy saying do not reconcile that field.
Yeah. And
for deployment and things like that.
Have a policy, Caverno policy or something like that that simply doesn't allow it. And there you go.
Exactly.
Okay, from Stefan, I'm a computer science educator and wonder what would be a good strategy to teach students software development in the age of AI. Victor, your videos are already an inspiration. Thank you. I don't have the answer to that because I have conflicting opinions there. On one hand, I think that everybody should understand at least basics, no matter whether you work on that level or no, right? You should understand what is Linux, how it works, what are containers, and so on and so forth, right? On the other hand, I honestly don't know how will the world, today's students, how will the world look like when today's students become software engineers. I honestly don't know how will that look like. It will be very different, that I'm sure. When I say very different, let's say 5 years from now, right?
Yeah. No.
I don't know.
And I don't know either. The only thing that I will say is we can't deny AI. We have to learn how to use AI. And I think a major part of this is teaching people. There was a place that I was at once where when they wanted to see if you knew how to program or if you would be right for the job, they came up with their own fake programming language. That was the stupidest, most simple programming language in the world with like 9 different commands in it, basically. And they gave you all these tasks that, okay, go and write the program in the most efficient way. And the idea was, I don't care what existing knowledge you have right now. I want to see how you think. I want to see if your mind has the thought process of software development. I think that software development is a mindset, and that's what has to be taught way more than a specific technology, because technologies change all the time. And even in the world of AI, when we're vibe coding, right, or we're doing anything like that, even in vibe coding, you can't just say, hey, write an application that does these million things. You have to think like a software developer and break it down into the relevant tasks and understand what the steps are and understand all of these different levels. You have to think like a software development mindset. And therefore, I think the most important thing is to teach that mindset way more than teaching Java versus C# versus Python. It doesn't matter.
I think that actually what you're saying now, I think that that's true even without AI. I feel that people put too much emphasis on, I know Java inside out and stuff like that. I believe actually that a really proficient software engineer, right, is not a person who spends 8 hours a day writing code. I think that that's the easiest part. Right? The real job is figuring out what should we develop, how should we develop, what is the architecture of that something, what is the flow of that something. I would say that even without AI, actually really good engineers are spending vast majority of their time not writing code. Or, sorry, when I say writing code, not writing production code. It could be code that proves a hypothesis, that shows the design of something. So not necessarily not write code, but not write production code. The writing production code is, in my head, and this is without AI, the least important thing. And I know that people freak out when I say that, kind of, I'm, beautiful code, and that's great. Being proficient in coding is great. Yeah. It's not the job of really good engineers. Or, sorry, not the primary role of really good engineers. And with AI, I think that AI is just making that clearer, right? I can, if I'm good engineer, right, I can, in theory at least, vibe code it everything without writing a single line, and it will be good not because AI is good at understanding my vibes, but because I know what to tell it, how to do it, where to do it. I know to say, this is horrible, this is crap, don't do it like this, right? And so on and so forth. Right. Redirecting AI, how to do the right thing, that's the skill, right? And that skill exists is equally important, maybe not equally, but important even without AI.
Right. I tried this, by the way, just to see like how it would go. I have never written code in Rust. Thank God, because I looked at it and I don't like it. But what I did was I took a project that I have in Go, very simple, like internal tool that I use, and I went and vibe coded it in Rust. And then I went and gave it to a friend who writes Rust code. And I said, how is this code? And he said, actually, I would do these few things different, but it's actually not bad at all. And one of the things that he didn't think that it was vibe coded at all. And I didn't write a single line. And the reason simply is that I knew what I wanted. I knew how I want it to be done. And I knew what the logic was. Now, I may not know Rust very well, but if you understand one or two programming languages, you can read any code.
Yeah.
Basically.
Except Perl. Except Perl. You cannot read Perl.
It was the first language that I learned. So
okay, maybe you can.
I know how. Perl is a language that you know how to write, but don't know how to read.
Unless it's written by you. Unless it's written by you. If you wrote it, you know how to read it.
I'm sorry, but Python is the worst in that level. I'm sorry, but how does a for statement have an else? There's for else. Did you know that in Python? That you can do a for else?
It's been so long that I don't remember anymore.
And the else in Python runs only if the entire for loop succeeded after it went through its iteration. So it doesn't even make sense like in language. Okay, that's the worst language on planet Earth. I'm sorry, but it just makes no sense, Python. However, what I will say is that like you understand the language. You understand, and you can understand even if you're not an expert in Java, if it's doing something that doesn't make sense. Right? You can do that in any language. So teach practices, not technology.
Exactly. Okay. Any thoughts on Graphana Alloy and also versus Hotel Collector? I'm going to let you run. I know you have a run on this one.
The answer listen, this comes down to very simply, in my mind, it's similar to Podman versus like Docker or containers versus, WASM. Okay. Is WASM better than containers? Yes. Should you use WASM instead of containers? No. Is Podman better than Docker? Yes. Should you use Podman instead of Docker? No. Is Graphana Alloy easier to configure, more feature-rich, more interesting than OTel Collector? Yes. Should you use it? No. The reason is that OpenTelemetry is the de facto standard. I love Graphana. I love a lot of the stuff that they do. However, I do not believe that replacing standards is the right way to go. I think that OTel Collector is what we have agreed on as an industry, and I don't like... by the way, I have a major issue also with all of the large monitoring companies, observability companies that have their version of the OTel Collector also, right? Like, at least Grafana are honest about this and went and created Grafana Alloy and created their own project because they weren't happy with OTel Collector itself, instead of all these Datadogs and all these companies that are coming and creating the Datadog OTel Collector and the Splunk OTel Collector, and they're all forks from the actual open source project, and I don't like that. So the answer is use open source OTel Collector. Now, by the way, you can sell OTel Collector. You can send it to Grafana Alloy if you want its configuration. You want some like advanced filtering and things like that. But OTel Collector always needs to be in the picture, because if it isn't, you've locked yourself into a technology. You've locked yourself into a specific implementation also. and not into a open standard that has taken over the entire industry. And I'm against that.
Let me just add that I don't think that it's necessarily by default bad to lock yourself outside of the standard, but there must be a good reason for that.
Correct.
Standards become standards because somebody chose to abandon previous standard, right? Whatever the standard is. Standards change, but Alloy, I don't think, provides sufficient value or does not change the game. Let's put it that way, right? Kubernetes emerged as a new standard as opposed to whatever was there before. And you should use it, right? And not stick to the old standard. But there was a good reason why Kubernetes emerged. And it was sufficiently different. It's not only slightly better, but sufficiently, this is a different way to do things. And then, go outside of the standard, right? But Alloy feels like, to me, it's the same thing, just slightly different.
Right. The only time I would ever say Grafana Alloy makes any sense is if you are a Grafana Enterprise customer and you want the full stack support from a single vendor and you want the Apple experience. Okay. I hate Apple, by the way. Victor knows this. My hands do not touch Apple devices. Like, no. But there is something nice to say about the walled garden that Apple builds you and the nice integration of all their tools. The same thing can be said. Alloy plus Loki plus Promptail plus Grafana plus Tempo plus all of these things that have very nice integrations with one another. If you're all in on the Grafana stack and you need enterprise support and you want enterprise support on as much as possible, great. Then Grafana Alloy, in that case, Alloy may make sense to you because anyways, you have basically locked yourself into a specific vendor by going with their entire stack. I still think that you should use OTel Collector and send from OTel Collector to Grafana Alloy.
In that case, maybe you shouldn't.
In that case, maybe not.
Because then you're actually, you're not benefiting from the money you already gave to, in this case, Grafana, right? I'm already paying you to take care of this and to guarantee certain SLA and what's not, and I'm already giving you money. Why not? Right.
Exactly. And that's why I said in that case, it's the only case where I think that Alloy really makes sense, unless it can do certain things that OTel Collector can't. At which point, if you reach those very, very, very specific edge cases, then also maybe it makes sense to use it from an open source perspective. But I really see Alloy as just an enterprise solution that good for Grafana for releasing it to open source, because I like the fact that they do release things open source and that they really are a strong open source company.
Okay, next one from Noam. Hi guys, I have heard a lot about the Cilium sidecarless service mesh. Do you think that sidecarless service mesh is the future? I don't think it is the future. It is the present.
Yep.
Sidecarless is here now. It's not something that we should hope for the future. You should use it today. It is the present. What will happen to Istio? Istio is already supporting sidecarless model. What will happen to Linkerd? I have no idea. I cannot understand why they're not moving in that direction.
Linkerd will stay like mainframes in my mind, where there will be some people that still use it because they've always used it. But the real difference between the different meshes today is becoming so minor in many cases because we're all unifying around Gamma, the Gateway API interfaces. So Linkerd used to have a nicer and more simple API over Istio. Yes, that's why I used to prefer Linkerd. Then Istio started working with Gamma. So did Linkerd. Istio added Ambient Mesh, bye-bye Linkerd. Right? Like
exactly.
You have to stay up with the standards. It's like what we were saying before around standards on OTel and all that. It's the same thing here. The standardized way today is not to do with sidecars because there are so many issues with sidecars. of, the amount of extra resources. You're just like doubling your amount of containers running in your cluster randomly. When most of your pods don't need that. When you want to update your service mesh, you have to roll out all of your pods. It is a nightmare. Versus why just use eBPF technologies and have it run on the node as a daemon set. And for those things that need these specific capabilities that can't be done today through eBPF because the hooks don't exist and fine. So for those, they have the proxies. It's basically envoy proxies that do the things for you in most service meshes, but that it goes up to a separate pod on the node. Like, there's really no value in my mind today to a sidecar-based service mesh at any level. Ambient Mesh for Istio is the way to go. If you're using Cilium, I can understand the approach saying use Cilium Service Mesh because it's already installed in your cluster, the key components. So just like have it all be one thing and it's easier that way. So I can definitely get that. If you're not using Cilium like me in most of my clusters, so just use Istio. Istio is a more feature-rich service mesh than Cilium's implementation till today. But I think that Cilium's covers probably 75% of the use cases of customers. So if you fall in that 75%, great. Now, let's be honest right now that 50 to 60% of Kubernetes production environments today, at least, are not using service meshes. So when I say 75%, all of those that aren't using service mesh, go to Cilium if you're on Cilium right now. Like,
not only that, but if it would be choice whether to use Cilium or Istio, then I would say, okay, think about it, because switching later could be hard. But there is a chance that you're using Cilium as CNI, and then Istio is something that you would put on top of it, right? And then you can easily say, okay, so it's not necessarily the decision I need to make today, assuming that you're using Cilium, which could be a separate discussion as CNI, right? You can say, okay, Cilium is fine. It does what I needed to do. And then tomorrow you reach and say, okay, I need more, those 40% or whatever that Scott was mentioning. And then you add service mesh on top. You're not replacing Cilium, right?
Right. I think that one of the key ones, the only use case where I say, even if you have Cilium in your cluster, that I still say, even if you don't need the capabilities, that it makes sense to use Istio, is if you are planning on being multi-cloud and you're planning on being in specific clouds, let's say AWS, where you want to use VPC CNI when you're in AWS and not to bring your own CNI. As far as I know, Cilium Service Mesh requires you to also be using Cilium as the CNI, and it can't be installed on top of another CNI because it basically just extends the CNI's capabilities. And because of that, if you are planning on, if your growth plan right now is to run also on, let's say, EKS clusters or to run on, I don't know, Tanzu clusters, or to run on whatever distributions it is that don't have Cilium as a CNI, then go with Istio because it's a standardized and will run on any CNI, and you've decoupled yourself.
I would say it's not really then go with this Istio. It's first step. Okay, so if your distribution comes with baked-in CNI, use it.
Exactly.
And then at some later point,
mesh,
you say, I need more. Yeah, put Istio.
Right. That's what I'm saying. When you choose which service mesh to use, those are the cases where even if right now I'm running in GK with Dataplane V2, which is Cilium based, right? So I can use Cilium service mesh, I believe there. Or Azure with their Cilium, right? And that's where I'm starting right now. But I know that in 6 months, I'm also going to be adding, let's say, AWS, right? Or something like that. Then if you're doing service mesh, just go with Istio because you don't want to have Istio here, Cilium service mesh here. They're using different versions of Gateway API, and it's just standardized.
Okay, Shabir. I always debate that Kubernetes itself is not best for GitOps. since it does modify your resources when applied with all sorts of mutations. How do you get confidence when you have mutation webhooks? There's a lot there. First of all, I would argue that actually GitOps is primarily Kubernetes concept. I know that there is some ways to do it with Terraform or what's not, but just to make it clear, when I say GitOps, I mean 4 principles of GitOps, one of them being pool-based model. We might argue that that's not a good idea, cool, but it's not GitOps then, right? So some people, when they say GitOps, I use Jenkins, kind of like, no, it's not GitOps.
All right.
Just to be clear.
Well, no, I use GitHub Actions, so it is GitOps because it has Git in the name.
Yeah. So basically, excluding few outliers, vast majority of GitOps usage is in Kubernetes. So
Yes.
if Kubernetes is not the best choice for if Kubernetes is not the best choice for GitOps, I would say that GitOps is not an option most of the time.
Right.
Mutations. Now, I have a hate relationship with mutations. I think that there are good mutations. Like we mentioned Istio, right? If you annotate, I forgot whether it's annotations or labels. I think annotations, right? If you put them on a namespace, then when you deploy something to that namespace, the mutation will happen, and those similar, if not the same, annotations will be added to your resources so that Istio knows that, hey, you're part of service mesh, right? But those are the cases where mutations make sense, and Argo CD and Flux already know not to mess up with your annotations. Now, the mutations I don't like is, I'm going to create a mutating webhook that will always put, 3 replicas on a deployment. I don't think that that's a good use case for mutations. Because it complicates things. Then I don't know, okay, so what is the intention there, right? Kind of like, if I look here at GitHub, do I understand what is actually supposed to be running in production? Do I see 1 replica over there and 3 replicas over there and so on and so forth? So I'm not very fond of mutations, except in special cases, usually to third parties.
Right. And again, like I in general agree, like I think that mutations need to be very carefully thought about before done. However, what I would say is that I'll agree with you, Victor, and just elaborate on one point there, which is Kubernetes. Like you could say that GitOps is not actually declarative in Kubernetes when I put a deployment there because, well, the deployment is just a record in a database and that ends up going and creating another record in a database called a replica set, which ends up creating a bunch of other records in databases called pods that something else is watching and actually schedules containers running. So if we wanted to be declarative of what I want, you would actually be putting the CTR commands that go and run the low-level container in the Linux namespace in Kubernetes. The answer is what is your desire? Is your desire to have 3 replicas of a specific application, of a specific container image, always running with this basic configuration? If that's my desire, then Kubernetes GitOps is great. You just have to be very clear on what your desire is. And as much as Kubernetes is always going to add things. It's going to add the last applied annotation, and it's going to add the UIDs, and it's going to get a crazy
events,
concept. It's going to add all this
statuses,
and events, and because it's a living system. And that's perfectly fine. That's not anti the process of GitOps because my desire is still happening. I have an issue with mutation policies that change things. I have no problem with additive mutation policies. Additive mutation policies, in my mind, can come as much as they want. You want to add extra decorator labels for your environment so that when it goes to the centralized observability tools, it has all this stuff. Great. I don't care. Don't make the developer supply the 30 labels that you care about for your monitoring. Have a mutation Kyverno policy that goes and adds those. Great. Because from the developer's perspective, the deployment, they don't care about that. That's you. That's spec. You as a platform team care about it.
It's effectively spec that you care about.
Exactly. And that's what's very important. Now, I also believe that just like we had mentioned before, you shouldn't be putting replicas in your manifest because you should be using HPA or KEDA or things like that in order to handle the replicas. And that is very important. By the way, same thing in cluster API. Never put replicas on a machine deployment. Use annotations for cluster autoscaler to do autoscaling for you, right? Like all of these things, like you should not be specifying replicas in a dynamic world unless it's a stateful service. Let Kubernetes deal with that with these autoscalers. I think the same thing, by the way, in my mind, goes for resource requests and limits with tools like ScaleOps or Perfect Scale or the 25,000 other tools. ScaleOps is my poison of choice, but is to use a tool that also handles that for you, right? And it is not less declarative if I don't put my requests and limits and don't put my replicas in Git. I'm just saying that's not my desire. My desire is for the cluster to deal with that, so I'm not specifying it, right? That's all that you're saying. In Terraform, you don't supply all of the fields. You supply what you care about, and defaults get filled in. That's the way that APIs have always worked throughout history.
And that's, to me, that's also similar in way of me correcting people when they say, previously said that I really dislike when people say, hey, it's CD. It's not CD. GitOps. Also, I really get upset when they say, hey, I have the actual state in Git. You don't. You have intention in Git. You have desired state. The real state is not even your deployment in your cluster. The real state, the actual state are your pods. And even that is debatable, right? And your storage and your load balancer and your what's not. Kind of like, that's just intention. I would like to have this. That's what you're saying with GitOps. It's not. Exactly. It's not a record of anything. It's outside of intention. It's not a system of record. Just to make it Git. Right. Just to make it clear.
Yeah. And that's where I will say once again that Victor was very wrong a few months ago when he said that, Helmcharts in Git, like he was against Helmcharts being deployed with, via GitOps and whatever because it's not declarative. Really. And I just was listening to that recording the other day because Helmcharts are too all over the place. And I agreed with you then, right? Like I agreed that Helmcharts are very imperative. They are not a declarative format. However, saying I want to deploy a Helm chart is very declarative. Meaning the fact that me saying when I create a Helm release of FluxCD, that is as GitOpsy as a YAML manifest of a deployment. Because what I'm saying is my desire is I'm just giving more control to someone else, right? But my desire is to have this Helm chart installed. Okay, that's a desire. My desire can be I want this pod. My desire can be, no, I want a higher level of abstraction. I want a deployment. Can be, I want a higher level of abstraction. I want a CRD based off of a crossplane composition. Can be a level higher and say, I want a Helm chart. And that's perfectly fine. It's just a question of GitOps is not saying the actual state. It's saying what my intent is and what do I desire. And I can pass as much or as little to the cluster as I decide that I want.
I agree with that. It's not declarative, but doesn't mean that declarative is the way to go always.
And you can declaratively install something that is imperative.
Yes, absolutely.
A Helm release of FluxCD is declarative. Do we agree on that?
Yeah, exactly. I mean, it depends actually which level. If you're looking, if you argue, and then I definitely agree, kind of like my declarative intention is actually the Helm values file.
Right.
That's my...
Exactly.
Yes.
Exactly.
That would be equivalent, basically, of crossplane composition, right?
Right. Yeah. That's my intent. Now, the fact that goes and runs imperative things, what's a controller if not an imperative set of code that is running against something and trying to make it? So when you create a deployment, that is imperative and not declarative because a bunch of code is running against that that's going and creating other things and do it, right? So all of these things are imperative in the end. The question is my intent declarative or not? And that's where we need to go.
Okay, next one from Thomas. Should AI handle routine tasks with clear outcomes? Writing encyclopedia-size instructions, hoping it doesn't hallucinate is kind of insane. Okay, there again, a couple of things there. Let me actually start with the end. AIs do hallucinate, but so do humans. Just to be 100% clear, kind of like we hallucinate all the time. Yes. Whether that's a good thing or a bad thing, that's a separate discussion, right? But we hallucinate as well. So kind of we're disliking. Now, the level of hallucinations and so on and so forth depends in case of AI in great part on what you ask it to do, how specific you are, and so on and so forth. Now, routine tasks. I would not use AI for routine tasks ever. I might use AI to write the definition of routine tasks. But if I need, so let's say a simple one, right? Run tests, right? Why would I use AI to execute tests as opposed to a script if execution of those tests should always be the same? Always the same. Outcomes are not the same, right? So the predictable things are better off as scripts, workflows, code, right? Kind of, I want to do this thing exactly the same over and over and over and over again, right? So I don't think that AI is replacing those. I think that AI is replacing more the things that we humans are doing. Like, hey, me writing code, that's not repeatable. That's always different code. Or it should be. I know that for many developers, it's just copying and pasting the same thing. But that's creative in a way. That's different. That's analyzing things and figuring it out and so on and so forth. That's what AI could be good for. I'm not even going to say is, right? So don't use AI for routine tasks. It doesn't make sense. Like that MCP that I was saying, meshing before, that I'm working on, I embedded actually agent inside of that MCP. And then there are different things that MCP needs to do. Like, hey, fetch all CRDs. I'm not asking agent to fetch all CRDs because it's kube control get CRDs. It's always the same. There is no good reason why AI would do it. Right? But then
A, it's going to be slower. B, it's going to cost money. C, it may get it wrong sometimes. And therefore, things that are predictable, have them be hard-coded.
Repeatable. Exactly. And repeatable.
Yep.
But then, hey, if the outcome of this something, whatever that something is, will potentially be different every single time we run it, that's a human task or AI task, depending on which one you're using. Like, if I go back to the tests example, right? Executing tests with AI sounds silly. It's a waste of time, waste of money, waste of resources, waste of everything. Now, if you want to analyze the results of the tests and if they fail and do something, that's a human task or AI task. That's not something you're automating.
Exactly. That's where I've always said a Jenkins pipeline should never be AI, but a Jenkins pipeline, when it fails, should auto-trigger a collection of the logs and the data and send that to an AI agent to summarize and give a root cause analysis and how to fix the issue that caused the failure in CI, right? Like, you use AI for the debugging, not for what you are debugging, right? You use it to debug.
It's the same thing like with applications. You can use AI to write the code. I don't see AI being the code itself, right? Kind of because that application, when I click this button, should always do the same thing.
Yes.
Right? It's as easy as that. Okay, another one. Cilium can, this is more of a comment, I think. Cilium can work in hybrid mode, still uses VPC CNI while skipping eBPF capabilities, I guess. Great.
It can. It has some limitations. It's mostly used for network policies, as far as I know, with the implementation with VPC CNI, because it uses CNI chaining. It works. It's quite limited. It doesn't get all the capabilities because it still passes the data path out to VPC CNI for many things.
Okay, from Hard R. What are the biggest stumbling blocks in running an air-gapped failure over C? Kubernetes cluster
failure
the
averse.
internet. Failure reverse.
Failure
Okay.
averse.
Yeah. Kubernetes cluster where the internet can go down and the cluster is unaffected and also can still build from source. This is your domain, so I'm going to let you answer, Scott. I'm just going to comment on the last thing. Internet can go down, your cluster is most likely still working. And if it's not working and internet is down, then most likely your users cannot use it either, just to be completely clear, right? And building from source, you can still build from source without internet. That's not directly related with the cluster. But I'll let you, Scott, answer because this is
building from source without internet is only possible if you have internal artifact registries that you're pulling from and you're using those mirrors and you're using in your POM XML, you're pointing to a local artifact or your Nexus or Docker. You're pulling from
I was referring, who did the last commit? Bring your laptop here. And build
Good
it.
luck. And if the cache was invalidated, and if they did a make clean or like no.
But what I'm trying to say, and I will let you answer just quickly, is that when there are many things about air-gapped, but kind of losing internet in my head tends to be the least of the concerns in general. Kind of like probably not the major.
So I will say a few things here, and the biggest stumbling blocks are the things that people don't think about, right? People in an environment, well, in fully air-gapped, obviously you think about everything because you're fully air-gapped, so you have no access to the internet. So, it's going to be a challenge always, but you never have issues if the internet goes down because there never was internet in that environment. If we're talking about network challenged environments, as I like to call them, where, the internet can all of a sudden go down for a day, can go down for an hour, where it's not a stable network connectivity. Let's talk about some like edge locations and things like that. Typically, the challenge that we see is that customers don't, and people don't actually think about all of their dependencies. For example, like what I was saying with building artifacts, if you're mentioning here that you need to be able to build from source, that means that you need to make sure that you are not pulling any dependencies in your build process from the internet. That means your Docker file from statement. That means all of your apt repositories or APK repositories or whatever base image you're using and all of those packages that you're downloading into the container image in its Docker file. That means all of the build packs if you're using build packs. That means all of the jars and all of the NPM packages and whatnot or the PyPI packages that you're using when you're bundling things and you just add in your requirements TXT that I need requests. Well, requests has to exist locally, and you have to set up Python to read from your local Python PyPI registry. So that's a major thing, number one. Number two, people do not think about this, but Git, and I don't care right now, GitHub, GitLab, Bitbucket, Azure, DevOps, Git or Git, right? Because there's two, one with two E's and one with EA. I don't get why there need to be two with the exact same name, but whatever. But all of these tools, Git has become a critical entity within our environments. It is as critical as your container registry, basically, because that is where all of your state is coming from today to a cluster. You don't get the desired state anymore if you don't have that. So you have to make sure that Git
or NPM packages.
NPM packages just means that I can't rebuild something new.
Yeah.
But if I don't have Git, that means that it can't deploy the release that is already there. It means that I can't promote. It means I'm much more limited because my GitOps is broken now. And that's how I apply. That's where my state is, right? So that's like saying my backups are down when you have a disaster. Not something exactly that you want. So that is going to be very critical in my mind. Git, people typically forget about because they think of it, oh, that's a development thing. No, that is also an operational thing today because we have made it that way with GitOps. So you have to think about that and think about everything. Like many companies that I go to say that they're air-gapped and then they're using like Azure Entra ID for authentication. I'm like, so you're not air-gapped, you're just internet challenged. You're only open to 3 or 4 URLs. But if you're using Entra ID, you have access to internet because that is a internet service. So make sure what air-gapped actually means. I have thought about this with vendors. I've thought about this with customers many times where vendors say, yeah, we have air-gapped support. You can add a proxy. I said, no, that's not air-gapped. Air-gapped is where there is a gap of air between network, there is air in between. There is a gap. That is what air-gapped means. But then there are customers who say, I'm air-gapped, but I'm using Entra ID. So no, you are not air-gapped, right? Like the terms mean something. So we just have to be careful with what we call air-gapped.
Which does not mean that it's necessarily bad being partly air-gapped. Just to me, that's similar to kind of like GitOps discussion.
Being network challenged is not bad. Most companies should be network challenged. I have a major issue with companies that are just, oh yeah, we're open to everything. Have a nice day. Like that's, okay. If you work at a company like that, let me know. I have a few hacker friends that will definitely have a nice day. Right? Like that's a terrible idea. To be just open Wild West. So you should be internet challenged. Now, how internet challenged do you need to be? Comes down to what industry you're in, how much regulations you have, things like that. That is where we should almost always be, is in that internet or network challenged world. Not in the full air gap. That is a very limited subset of companies that actually should be in the full air gapped environments, mostly in the governmental security type things. And in the full open to the internet, no one should be there. You should all have a firewall. That's blocking things.
That's it's simply you should. There are almost never cases where you should be religious about any particular topic. Oh, I need to be 100% air gap, or I need to be. I have to be prepared for multi-cloud, or I have to be this, or I have to be that. Use logic. I kind of secure things that are important to be secured, right? That's not necessarily everything. I hate when I've worked together, not in companies like that, where actually being air-gapped and what's or not means that nobody can actually do anything, including the people who are supposed to be doing something. Anyways, I think that we are out of time. There are like 5-6 questions left. I'm sorry, everybody, but you need to be faster next time. Come sooner. Type your questions faster. And I'm really sorry because I really wanted to answer the second unanswered question about Humanitech, but then I would feel bad skipping Juan Carlos' message. So that's it for today.
What do they do, Victor?
Humanitech.
Yes.
I don't know. I don't think that anybody knows.
We can leave it there because we agree.
My question, the only question I have, is whether they can know what they're doing. Can explain.
I don't know. They've tried multiple times with me and they haven't succeeded in explaining.
With me either. So I'm wondering, I'm trying to be optimistic here, and maybe I run into wrong people. Maybe there is somebody else who knows.
Which is why, if anyone from Humanitech sees this, I will be at KubeCon, so will Victor. Please, both of us are more than happy to sit down and try and understand again what Humanitech does, because I am very interested in understanding. Let me know.
Just to be clear, I want to see it. I don't want another presentation with PowerPoint.
Correct. Right. Exactly. I want actual, what you do. Like, please. And by the way, thank you guys for leading the platform engineering org and all of that. I will say, awesome. Thank you guys for doing that. But yeah, I still don't know what the company does.
Thank you everybody for coming. See you next week. Cheers.